Hi everyone, I hope you are doing well. My name is Samia and I am second year PhD student at University of Trento in Italy. Before I start, I would like to express my gratitude for the opportunity to present in this conference. Today I will present my paper titled Optimizing Intrusion Detection Performance throughout Synergistic Hyperparameter Tuning and Advanced Data Processing. Our presentation plan is to start with an introduction, followed by related work, problem statement, proposed network and tool detection system, result and discussion, and finally conclusion and future work. So here, the rapid development of computer, network, and internet technology has enhanced the global connectivity, but also increased the cyber threatening information security and property safety. Traditional network intrusion detection system, which rely on misuse detection and anomaly detection techniques, face serious challenges like low detection rate and high false positive alarm rate. As those methods struggle against sophisticated and evolving threats, researchers are turning to machine learning and deep learning technique to improve the efficiency of effectiveness, let's say, of intrusion detection system and adapt to the complexity nature of cyber attacks. In order to comprehensively define the cybersecurity, it's referred to the processes, guidelines, technology, and protection of defending cyber environment from malicious activity. The key terminology in cybersecurity include the vulnerabilities, which are weaknesses in the system that attacker can exploit to execute malicious command, access to unauthorized data, or conduct a denial of service attacks. Cyber attacks or intrusion are intentional actions designed to exploit information system using techniques such as malware, phishing, SQL injection, and man-in-the-middle attacks, aiming to compromise the system confidentiality, integrity, and availability. The zero-day attacks exploit the vulnerabilities known to the public and discovered by network defender, presenting significant challenges due to their unexpected nature. Due to the heavy reliance of information system, various approaches have been deployed to protect information systems, such as control firewalls, anti-malware, sandbox, and cryptography. However, due to the rapid growth of attacks, techniques, and zero-day vulnerability, such methods are insufficient for securing information system. Thus, an IDS, which is the main methods capable of preventing a wide range of attacks and even zero-day attacks, has become necessary in any organization security infrastructure. An intrusion detection system, it can be defined as the process of monitoring the events occurring in a computer system or a network and analyzing them for sign of intrusion. An IDS can be designed based on three detection methods, which are signature-based detection, anomaly-based detection, and hybrid detection, which combine both anomaly detection and signature-based detection. In this paper, we will focus in network anomaly-based IDS to build an efficient machine learning-based intrusion detection system. A network intrusion detection system developed using machine learning methods typically involve three major steps, which are data processing, training, and testing. During the data processing phase, the dataset is transformed into a format suitable to the use, where the algorithm which usually include data primary analysis, data cleaning, encoding, and normalization. The pre-processed data is then divided into training and testing set. In the training phase, the machine learning or deep learning is training using the training data set, and the time taken for the training, it's depend to the dataset size and the complexity of the proposed model. Finally, in the testing phase, the model is evaluated using the testing dataset based on its prediction. For the network intrusion detection models, the network traffics and stances are predicted to belong either benign or normal classes. Various machine learning and deep learning models have been proposed in the literature to address the intrusion detection issue. For example, here Kieman in 2023 applied a long short-term memory approach within a recurrent neural network framework and verified the effectiveness of deep learning for intrusion detection system throughout the performance of the testing. Back in 2020, introduced a clustering approach for intrusion detection system, integrating a mini-batch and principal component analysis to tackle the problem of high dimensionality in the NetFlow datasets. However, addressing one or two issues in an intrusion detection system will leave a gap in achieving generalized solution. Despite the advances in using artificial intelligence for intrusion detection classification, several major challenges remain. First, the traditional network intrusion detection assist approaches often use the dimension reduction to handle the large-scale data, but this can result loss in significant information and high false positive detection rate. Unbalanced data is another challenge, as it can negatively impact the model performance, leading to high false alarm rate and missing detection in the minority class sample. Additionally, the complex nature of network traffic data makes the feature extraction difficult, leading to poor classification outcomes if the right features are not fully extracted. Furthermore, deep learning models require optimization of multiple hyperparameters to achieve the optimal performance. In this paper, aim to address those challenges in intrusion detection system by implementing the following objective. We leverage the hybrid camis and SMOTE methods to effectively handle the imbalanced data issue in NetFlow dataset. Second, to manage the high dimensionality in the NetFlow dataset, we utilize the principal component analysis. We also incorporate the fast correlation-based filter for feature selection techniques to identify the most relevant feature from the dataset. Also, we employ the Bayesian optimization, specifically using tree-based Parsons estimator to effectively tune the hyperparameter of our models. The proposed network intrusion detection system, as illustrated in figure below, follow a systematic and comprehensive methodology to enhance the accuracy and the effectiveness of the IDS. Initially, the process involved data analysis, pre-processing, which include primary data analysis, data correlation, data cleaning, normalization, padding value adjustment, and data and feature selection to prepare the data set. Subsequently, the data is subject to the high dimensionality reduction using principal component analysis to reduce the dimensionality of and capture the most significant information. Then we utilize camis clustering in conjunction with synthetic minority oversampling technique To address the imbalance issue in NetFlow dataset, in the model training phase, the balanced data is split into training set and testing set, which are then used to train separate deep learning models. Those models are specifically designed to designed for network intrusion detection or network traffic classification, adept at distinguishing between normal and anomalous instances in the NetFlow dataset. Finally, the classification of hyperparameter optimization employ the Bayesian optimizer to systematically fine-tune the deep learning models. To evaluate our work, we used two different NetFlow datasets. The first one is CIC IDS 2017, collected by the Canadian Institute for Cybersecurity. The dataset consists of 84 features, including the label that classifies the type of traffic created. The dataset consists of 15 attack classes. And from the table below, the first thing that can be seen that the data is imbalanced and the benign traffic is higher than the other labels. The figure below illustrates the network infrastructure topology used by researchers to collect the dataset. To create a working test bed, researchers have implemented two networks called attack network and victim network. The victim network simulates a common network that generates benign traffic, and the attack network is an external network consisting of router and switches with a set of machines with the public IP addresses. Okay. The second data set is another version, another data developed by the Canadian Institute for Cybersecurity in 2018. The number of features extracted from this dataset using CIC flow meter version 3 is 80. And the figure below illustrates the network infrastructure and topology used for the collection of the data. The final output of running CIC flow meter was a CSV file representing the NetFlow data. Here we try to explain the data preprocessing techniques we used in this work. The first is the fast correlation-based filter, which is a feature selection methods used primarily for machine learning and data mining to enhance the model performance by reducing feature redundancy while maintaining relevance of the target of variable. In the context of intrusion detection system, the algorithm 1 provide a detailed overview of the FCBF procedure, highlighting its role in enhancing IDS performance. The process starts with computing individuals, a feature to class, and then feature to feature scores. The top ranked feature with a strong correlation to class label we're retaining, while the redundant feature are eliminating, ensuring a diverse and informative set of features. After feature selection, data is undergo high dimensionality reduction phase using principal component analysis. It's applied by computing the covariance matrix of the feature and obtaining its eigenvectors and eigenvalue. And the figure below visualize the results of the dimensionality reduction of the two used dataset in this work. Now we move to the data balancing. To balance unbalanced data set, we use the strength of both k-means clustering and the synthetic minority over sample techniques. Algorithm 2 outline the process of integrating k-means clustering with SMOTE for data balancing with intrusion within our intrusion detection system. The process begins with applying the k-means clustering to partition the NetFlow data in distinct clusters. Within each cluster, we identify the minority class instances within which are typically represent intrusions. The SMOTE is then employed to oversample those minority instances by generating synthetic samples. Here we will present the deep learning machine learning models we used in our work. First is the convolutional neural networks. For intrusion detection, begin with an input layer for one-dimensional flow data feature, followed by a convolutional and max pooling layer to extract the downsample feature. A flattened layer will shape data into one-dimensional vector connecting to dense layer with a ReLU activation and dropout layer to prevent overfitting, and the output layer use softmax activation function to meet the classification targeting 15 attack classes. The long short-term memory model has 7-layer architecture, including LSTM layers, dropout layers, and fully connected layer for multi-time series prediction. The hybrid combination of convolutional neural network and long short-term memory model combine the convolutional neural network's special feature extraction with long short-term memories temporal analysis, starting with convolution and max pooling, followed by batch normalization. The data flow into the LSTM layer with dropout for overfitting mitigation, concluding with fully connected softmax layer for classification. The visual geometry group 19-layer model, VGG19, it's a deep learning, a deep convolutional neural network. You use it usually for computer vision and image classification. Is used for intrusion detection on the NetFlow dataset with convolutional layer analyzing the spatial pattern and max pooling layer, downsample to retain essential feature. Flattened data is processing by fully connected layer for complex relationship capture with dropout layer mitigating overfitting, and the output layer using the softmax activation classifier for different intrusion types. Note that all the deep learning models are fine-tuning by using the Bayesian hyperparameter optimization technique. Here we will present our performance result using deep learning algorithm within the context of intrusion detection system. We use 4 different performance criteria, which are accuracy, which refer to the percentage of correctly predicted instances out of all instances. The precision, which refer to the percentage of the true positive prediction out of all positive predictions. The recall, which refer to the percentage of true positive prediction out of the total of actual positive, and the F1 measure, which refer to the harmonic mean between the precision and the recall. Starting with the experimental result of CIC IDS 2017 dataset, as shown in the tables below. Classification result in multi-class classification setting with 15 class targeted. The result showed that the model VGG19 stand out as the top performer across all the evaluation metrics with the highest accuracy with 99.26 of accuracy and 97.93% of precision. Notably, the combination of convolutional neural network and long short-term memory model also demonstrates a strong performance with high accuracy of 97.86% and a recall of 98.53%, making it competitive alternative. With the CIC IDS 2018 dataset, similarly, the VGG19 model outperformed the other models with the highest accuracy of 99.92 of accuracy and F1 measure of 99.33 of F1 measure on the average. Also, the combination of the convolutional neural network and long short-term memory model achieved a good accuracy with 95.82% and precision of 98.13 and F1 measure of 97%. Here we will compare the performance result of the deep learning models before using the hyperparameter optimization and after using the hyperparameter optimization in terms of training time, accuracy, and F1 measure. Without using the hyperparameter optimization, the convolutional neural network classifier achieved 93.72 accuracy in 156-second training time, while the long short-term classifier reached 96.01% of accuracy in 572 seconds of training time. When we used the hyperparameter optimization, the convolutional neural network classifier achieved a 94.02 of accuracy in 130 seconds. And the combination of convolutional neural network and long short-term memory displayed the high accuracy of 97.86% with significantly reduced training time of 84 seconds of training time. The same thing with the CIC IDS 2018. Without using the hyperparameter optimization, the CNN classifier achieved an accuracy of 95.13% with training time of 2076 seconds, while the long short-term memory classifier reached 96.04% of accuracy but required longer training duration in 2,989 seconds. When we used the hyperparameter optimization, the combination of convolutional neural network and long short-term memory model achieved a 95.82 accuracy with a significantly reduced training time of 182 seconds. Also, when we used the hyperparameter optimization, the VGG19 model attained the highest accuracy of 99.22 with training time of 524 seconds. Here we tried to compare our work with some existing approach in the literature, as shown in the table below. The bidirectional convolutional neural network model trained on NB 2015 dataset in 2021 achieved an accuracy of 90.25 and F1 measure of 90.45%, while our model trained on CIC IDS 2009 and 18, which is a large-scale dataset in 2023, achieved an accuracy and F1 measure with 99.22% and 99.33% respectively. To conclude here, in this paper we present an advanced intrusion detection system that combine deep learning and reprocessing technique to reduce, we try to reduce the false positive rate and the performance of intrusion detection system. The experiment results show that the VGG19 constantly outperformed the other model in terms of all the accuracy. This success is related to its feature extraction and transfer learning, robustness, and generalization capability of the model. In the future work, we plan to enhance our intrusion detection system by exploring ensemble strategy that adapt to evolving attack pattern. Thank you for your attention, and